The purpose of this demonstration is to show the law of large numbers. Now, the law of large numbers is a pretty powerful concept. So what we're going to do is we're going to kind of set up the foundation for this, and we're going to run an experiment. So observe a random variable x very many times. Now we're going to use a die to simulate this random outcome of this variable. In the long run, the proportion of outcomes taking any value gets close to the probability of that value. Now this has been established mathematically. And the law of large numbers says that the average of the observed values actually gets close to the mean of these random variables. So what we're going to do is we're going to take one single die, and we are going to roll it one time for right now. When we roll the die, we get the value of 5. So my random variable has taken on the value of 5 at its first roll. Now if I roll this 10 more times, what we get is we get all these different rolls, but what's being plotted here is the average of the rolls. So we have the number of rolls being compared with the average. And according to the law of large numbers, eventually, with enough rolls, this up and down behavior that we're kind of seeing here should actually start to level out. And more specifically, it should level out close to the actual mean of this random variable. So if I roll this 100 more times, we see that we have the averages being computed with each number of roll that's being taken on here. Okay, now we see that the oscillations are not very big right now because we have a lot of rolls being performed. If I actually show the theoretical mean, we see that right now we're leveling off, but we're leveling off a little bit above the mean. Now keep in mind, we have only rolled this die 111 times. The situation involves that there's very many times. We're talking thousands and thousands of rolls at times. So if we roll this another 100 times, what we should begin to see a little bit is this behavior here starting to get a little bit closer and stay a little bit closer to this green theoretical average. And this is essentially how the law of large numbers works. The law of large numbers is different from the central limit theorem in that the law of large numbers says that after many observations, the average that you're seeing from these observations, as you recompute the averages when you incorporate new observations, you should eventually be getting close to the theoretical average. And that is what we see here with this simple experiment. A lot of chaotic behavior at the beginning here, but eventually some settling down and getting close to this theoretical average. And this is how the law of large numbers essentially works.